In this video, we will learn how to calculate volume from equations. We will start with a question. What volume of hydrogen will react with 24 dm cube of oxygen to form water? The first step is always to create a balanced equation. So, we'll start with H plus O equal, get you H2O. Both hydrogen and oxygen are present as diatomic molecules in nature. So we'll write H2 plus O2 giving us H2O. There's two hydrogen in the product side, one oxygen in the product side, two hydrogen in the reactant side, and two oxygen in the product side, two oxygen in the reactant side. So we'll make this 2H2O, H2 plus O2. The oxygen levels are equal now, but there are two extra hydrogen in the product side, so we'll do this. I did this fast because we already discussed how to do this in the previous videos. So our balanced reaction will be 2H2 plus O2 giving us 2H2O. So this is basically 2 moles of hydrogen reacting with 1 mole of oxygen to produce 2 moles of water. Before moving ahead, we should recall that the Avogadro's law states that all gases at a given temperature and pressure will have the same volume. So if 1 mole of oxygen has a volume of 24 dm cube, 2 moles of hydrogen will have a volume of 24 into 2 dm cube. That is 48 dm cube. Let's look at another question. When sulfur burns in air, it forms sulfur dioxide. What volume of this gas is produced when 1 gram of sulfur boils at STP? We need to write a balanced chemical reaction. So S plus O giving us SO2. And then S plus O2 giving us SO2 because oxygen is present as a diatomic molecule. And this is our balanced reaction. Over here, we have to convert 1 gram of sulfur to moles. So, the formula is moles equals mass by molar mass. Over here, we have the mass, so 1, and the molar mass or the atomic mass of sulfur is 32. So 1 divided by 32 is 0.03125. 0.03125. This mole value now has to be converted to volume. So we'll take the volume formula, that is volume by 22.7, and then over here we have moles. So 0.03125 equals volume by 22.7. So if we multiply 0.03125 with 22.7, we should get the volume we want. If you do this calculation, you will get your volume value as 0.71 dm cube. Now over here, we said 1 mole of sulfur reacts with 1 mole of oxygen to produce 1 mole of sulfur dioxide. So when you're taking 1 gram of sulfur, we are saying that it is 0.03125 moles. So if this is if sulfur is 0.03125, this is also 0.03125, and this is also 0.03125 because the ratio is 1:1:1. And all, since all of them have the same moles, number of moles, so because of that, and considering the Avogadro's law, and because they are at STP, they will have the same volume. So if this has a volume of 0.71 dm cube, our volume of gas produced, so this will also be 0.71 dm cube oxygen. What volume of this gas is produced? So what volume of this gas? They're asking for SO2, alpha dioxide. It will be 0.71 dm cube. Because the same moles of all of them are taken. You burn 6 grams of carbon with plenty of air. What volume of gas will form at RTP? What volume of gas will be used up? RTP is room temperature and pressure. This is just another fixed temperature and pressure like our STP, and the value for RTP would be 24 dm cube. So all gases at RTP would occupy 24 dm cube volume. So the first we'll have to create a balanced equation. And one important thing to notice over here is that it says burns with plenty of air. When it says burns with plenty of air, it means it will form carbon dioxide. If it burns with little bit of air, it means it's forming carbon monoxide. So over here we'll write C plus O2 giving us CO2. This equation is balanced. Oxygen is present as a diatomic molecule. So over here we have 6 grams of carbon. We need to convert that into moles. So we'll write mole equals mass by molar mass. Our mass is 6 grams. The molar mass of carbon is 12. So 6 divided by 12 giving you 0.5. So you have 0.5 moles. So, and over here, if we read this equation, we would read it as 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. So the ratio is 1 is to 1 is to 1. So if over here we are taking 0.5 moles, it would just be 0.5 is to 0.5 is to 0.5. So since all of them have 0.5 moles of all of these reactants and products are taken, the volume of all of them will be the same. What volume of oxygen will be used up? To find that, all we have to do is convert this moles to volume. 0.5 moles. Over here we were taking 6 grams of carbon, so we'll just continue with carbon. What volume of carbon? So 0.5 moles, 24. At RTP we have 24, so we'll do 0.5 into 24 to get the volume. It will occupy 0.5 into 24 is 12 dm cube. It's half of the value. So 0.5 moles or 6 grams of carbon occupies 12 dm cube. So if this occupies 12 dm cube, this will also occupy 12 dm cube. This will also occupy 12 dm cube. So the question asked what volume of oxygen will be used up. Your answer will be 12 dm cube. This is all for this video. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts about the video.